In this week, we're going to really just focus on the evaporation and the condensation part of the hydraulic cycle. Next week, we're really going to talk about the precipitation part. So what makes water so unique? Well, we know that water has three phases. We know that it can be a solid, a liquid, and a gas. And there's not that many elements that we're aware of that can be all three physical states. So in order for water to change between a solid, a liquid, and a gas, it requires energy to do so, and it requires energy in the form of heat. And so when we talked about different heat energies in the previous module, we talked about the three different kinds of heat energy, one of them being latent heat. Remember that latent heat is the energy required to change water's state. So the energy that is required to change water from a solid to a liquid to a gas is latent heat. So I'm sure that you're familiar with the terms evaporation and condensation. When we talk about evaporation, we're talking about water being converted from a liquid to a gas in the form of water vapor. And when we talk about condensation, we're talking about the process in which water vapor changes from a gas back to a liquid, both that require latent heat. Similarly, with melting and freezing, when we talk about melting, we're talking about the process in which a solid changes back into a liquid, and freezing, where we're talking about the liquid phase of water turning into the solid phase of water. But what you're probably not necessarily familiar with is the terms sublimation and deposition. Sublimation really just means the conversion of a solid directly to a gas. So when we talk about water, we're talking about ice going directly to water vapor. And deposition would really just be the opposite. So we're taking vapor and we're condensing it right to a solid. So a great example of that would be frost. So when we talk about the amount of latent heat that is required in order to change the phase of water, we think of water. In this example, we have three beakers here. On the left-hand side, we have a beaker of ice, so water in its solid form. We have a beaker of just plain water, so water in its liquid form. And then on the far right, we have water vapor, so this would be water in its gas form. So in order for water to go from solid to liquid to ice, and then back the other way, we need latent heat in order to do that. So when water goes from a solid to a liquid, and then from a liquid to a gas, what is actually happening? Well, we know that in order for water to become liquid again from ice, we know that the ice needs to melt. And so what happens in regards to latent heat? Well, think of it this way. If you are cold on any given day, what do you normally do to warm up? You stand by a heat source, you may put on a jacket or a sweatshirt or some other type of layer in order to stay warm, in order to what? Absorb heat. Well, that's what happens with water. When water melts and goes from ice to liquid to gas, water has to heat up. So therefore, latent heat is absorbed from the surrounding atmosphere. If you go the other way, when we go from gas to liquid to solid, what are we doing? Well, we're cooling water. We're cooling down the temperature of water. So in order for water droplets, or I should say water vapor, to become water droplets, that is condensation. And so heat actually has to be released. Why? Because we're cooling down water's temperature. So if you take our body temperature example, if you were outside playing, running around, maybe you're working out, working up a sweat, and you were originally wearing a sweatshirt or a jacket, maybe you were wearing layers, you were in a hot room, whatever it may be, and you realized that you were overheating and you wanted to cool down, what would you do? You would remove layers, you would take off your jacket, take off your sweatshirt, you would remove layers. Why? So your body has an easier time releasing heat. And so when you release heat, your body cools down. And it's the same idea with water. When water cools down, it releases latent heat to the environment. So when we talk about weather, we talk about latent heat being released to the atmosphere, and this is what we're really going to be focusing on for the remainder of this week's content.